Hi, welcome to the video on Half-Life practice problems. In this video, I'll be going over 3 practice problems using and showing you how to use these equations to solve these Half-Life problems. So before we begin, I want to go over these equations with you. There are 2 equations that we need to know for Half-Life problems. The first one is the number of Half-Life cycles, that's what HLC stands for, is equal to the elapsed time divided by the half-life. Now, when we say the number of half-life cycles, what we're saying is we're counting the number of half-lives. So, for example, if you have a radioactive isotope with a half-life of 5 years, in 20 years, if you have a substance with that radioactive isotope, in 20 years, 4 half-lives would have occurred or passed. So you know that you would have a lot less in 20 years because every 5 years it decreases by half. So you can do that math. You can count the number of half-lives by taking the total elapsed time, which is 20 years, and dividing it by the length of one half-life. So 20 divided by 5 gives you 4, and that will be the number of half-life cycles. So the number of half-lives and half-life cycles are the same thing. The second equation is the final amount is equal to the initial amount divided by 2 raised to the power of half-life cycles, or the number of half-life cycles. So this equation should also make sense to you. Let's say you had a chart where you had time and the amount, and you started off with the initial amount of 100. Let's say this was grams, 100 grams. And the half-life is 5 years. So in 5 years you would have 50, and in 10 years you would have half of that, 25, and you'll just keep halving it and so on. So in 20 years, you would have halved that initial amount, 100. You would have keep having it a total of 4 times. 1, 2, 3, 4 times. And again, this is the number of half-life cycles. So the math that it would look like is you're taking 100, dividing it by 2, then dividing that answer by 2, then dividing that answer by 2, and dividing that answer by 2. And that's the same thing as saying 100 divided by 2 to the 4th power, since you're dividing by 2 4 times. And again, that 4 is the number of half-life cycles. Okay, so that equation is the same as this. That's how you can calculate your final amount. All right, so with that being said, now let's dive into the problems. When we're taking on these problems, we do the same thing each time. We read the problem, we identify what information we're given, what we're asked to find. Then we use the find to determine which equation we're going to use last. Okay, so if you're asked to find, for example, if you're asked to find the elapsed time, then that's in this first equation here in red. So I would use this equation, I'll call it equation A last, and then I would use equation B first. So start with equation B, then I would use equation A. And I'm going to use equation B to get the number of half-life cycles. And then I would plug that into equation A and solve. So let's take a look at this example, see how that works. All right, so the problem is, what is the half-life of 100 gram sample of nitrogen-16 that decays to 12.5 grams of nitrogen-16 in 21.6 seconds? All right, what I want you to do is, first, all the information that I've underlined, I want you to identify what it is. Is it the elapsed time, half-life, final amount, initial amount? Okay, so the thing that we're looking for here is the half-life. So I'm going to put a question mark under that. That's our unknown. And this 100 gram is our initial amount. I'm going to give that an I. This is what we're starting off with. And it decays to 12.5 grams, so that's our final amount. That's what we end up with. And they tell me that happens in 21.6 seconds, so this is the elapsed time. I'm going to use lowercase et for that. So that's my elapsed time. All right. Now that I know my givens and what I'm asked to find, the next thing I'm going to do is I'm going to figure out which equation I'm going to use first and which equation I'm going to use second. Now remember, it's going to be based on what I'm asked to find here. Since I'm asked to find the half-life, and the half-life is in this equation here, the one with the elapsed time, I'm going to use this last. So I'm going to go ahead and use this equation with the final amount first. Okay. So I have my equation here, final amount equals initial amount divided by 2 raised to the power of the HLC. I'm going to plug in my final amount. So for the final amount, I'm going to plug in 12.5 grams. So I got 12.5 grams. I'll leave the units out for now. And for my initial amount, I'm going to plug in 100. Raise to the power of 2 to the HLC. All right, now I need to solve for my unknowns, and this is where the algebra comes in. So this is just an algebra problem at this point. I want to isolate my unknown. I'm going to use inverse operations. Whenever you have a fraction next to an equal sign, you can use cross multiplication as a shortcut to remove the unknown from the denominator of the fraction. So I have 12.5 times 2 to the power of HLC is equal to 1 times 100. Okay, the next thing I want to do is I still need to continue isolating my unknown. I'm going to divide both sides by 12.5 to further isolate my unknown. And when I do that, I get, I'll write it up here, 12.5 is equal, 2 to the power of HLC is equal to 8. So 100 divided by 12.5 is 8. Okay, now the question is, well, how do I isolate the unknown when it's a power? And that's where logs come in. Now, logs are an operation used to determine the power of something of a certain base. For example, if you wanted to know 5 raised to what power is equal to 25, you would use logs for that. Because log with a base of 5 of 25 is equal to question mark, and that answer, of course, would be 2. So that's what a log is telling you. It's telling you, oh, the power that you would raise 5 to get it to be 25 is the number 2. So that's what we're doing here. So with these numbers, you could actually solve this mentally. And the way you would solve this mentally is you would figure out, well, how many times do we need to multiply 2 together to get to 8? 2 times 2 is 4, times 2 is 8. That means that the half-life cycle, that power there, is 3. Okay, so you can do that mentally. But what if you wanted to use logs to do it? So what would that look like? For the log equation, it would look like this. You would take log base 2 of 8. Now, if you have a calculator that you can change the base, then great, you can go ahead and change the base. But I don't have a calculator where I can change the base. I only have 2 functions for log. The first one that just has regular log, that's log base 10. And this one is a natural log with where the base is Euler's number. So what I'm going to do is I'm going to use a special property of logs where I can solve this for different bases. And I forget what this property is called. It actually does have a name. So what I'm going to do is I'm going to take log base 10 and of 8. So I'm going to take the big number, so log of the big number, and then log of that little 2. So big on top, little on bottom. I'm going to divide these out. So I'll do log 8 in my calculator divided by log 2. If I press enter, it gives me 3. So as you can see, I still get the same answer, right? This is still equal to 3, so my HLC is equal to 3, and I can do it either using mental math by figuring out how many times I need to multiply 2 to get to 8. I can use, if I have a calculator where I can change the base of the logs, I can use that, or I can use this property of logs where I take log of the big number known as the argument and divide it by log of my original base 2. All right, and either way I get the right answer. Cool. So with that being said, we're not done, because remember, we're going to use both of these equations. So I use this first equation. Whatever equation I'm using first, I use it to solve for my number of half-life cycles, right? Where you're counting the half-lives. So now what I'm going to do is I'm going to take this value and plug it into this equation A. And let me just go ahead and rewrite that. So the number of half-life cycles is 3. I got that from here, so I can plug that in there. The elapsed time is 21.6. That goes here, and I'm looking for the number of half-lives. So let's go ahead and plug that in. We get 3 is equal to 21.6 over the half-life. And remember, when you have a fraction next to an equal sign, you can cross multiply. So that's 3 times half-life is equal 1 times 26, which is 21.6. All right, and then to solve this, I would divide both sides by 3. I'm just gonna do that there. Okay, and then this gives me the half-life to be 21.6 divided by 3. It gives me a value of 7.2. And now I need to know the units for this. So the units will come from whatever the units I use for time in my elapsed time is seconds. So the half-life is 7.2 seconds. Okay, so let's just quickly recap what we've done. First thing we did was we read the problem. We identified our given and find. Then we used our find to figure out which of the two equations we're going to use last. Since we were asked to find half-life, and equation A has half-life in it, we use that equation last. And that means we know we're going to use the other equation, equation B, first. We plug our values that we have, our final initial amounts, into equation B, and solve for the number of half-life cycles, which again count the number of half-lives. Now in solving this, we had to use logs, or you can solve for the half-life using mental math over here. After I had the number of half-life cycles, I then go to equation A and I plug in my information into equation A. I solve and I get the number of I get the half-life to be 7.2 seconds. That means nitrogen 16 decays by half every 7.2 seconds.